In this video, I'll talk about network symptoms and response actions. Before we can detect what's not normal on the network, just like with a host, we have to know what is normal. So ahead of time, it's crucial that we establish a normal network usage baseline against which we compare current activity to detect anomalies. Now, all systems on the network, or an individual host or a collection of hosts, could be affected by some kind of network compromise or malware infection. So, therefore, network traffic monitoring tools need to be in place, and they come in many different forms. For example, an intrusion detection system, or IDS, is either an appliance, could be a virtual machine, could be a hardware appliance, or it could be software that we install that detects anomalies and logs it or notifies administrators, but it doesn't do anything to stop it. Where an intrusion prevention system does take steps to prevent suspicious activity from continuing. Now, naturally, IDSs and IPSs need to be configured or quote unquote trained over time to determine what is suspicious. Now, a packet sniffer, such as the free Wireshark tool or even the Linux and Unix TCP dump command, can be used to capture network traffic so we can see what's going on, whether it's a wired network or wireless, to see if there are any abnormalities. Now, of course, there are ways to automate that so we don't have to do it and look for anomalies manually. One great symptom of a problem on a network is bandwidth consumption. Now, this might be happening for good reasons. There might be numerous streaming applications running that should be running, or people might be listening to internet music or news at work when they shouldn't be. Also, large downloads. If an IT administrator is downloading a DVD ISO image or Windows updates, that kind of stuff can take a lot of bandwidth. Now, depending on your equipment and your network environment, you might be able to throttle and control what type of bandwidth is available for certain applications, including downloading Windows updates and streaming apps. An infected host on the network could also be used for sending unsolicited spam email to many email addresses elsewhere. Or there could even be abnormal peer-to-peer communications over the network, and this could be indicative of a worm type of malware that self-propagates over the network between vulnerable hosts. So that would show up as bandwidth consumption on your network if your hosts are infected and being used that way. In the same sense, if a DDoS, distributed denial of service attack, is being executed because machines on your network are compromised and they're actually executing the attack, that again will show up as bandwidth consumption. So, like everything, we have to think that, a slowdown in network performance could be as a result of the network being used properly or improperly. Beaconing is used by some network topologies, such as Token Ring, where stations will beacon when they don't receive a transmission from their upstream neighbor. Now, at the same time, beaconing can be used in other ways as a heartbeat. For example, between cluster nodes, it's used to detect when a cluster member is down because we haven't received a heartbeat packet from it recently. So absence of a heartbeat could indicate a problem, in this case with a network link or a cluster node. So network usage baselines then establish what is normal. And what you might even do is use a packet capturing tool to capture traffic during normal business hours over time, perhaps a week, and then calculate statistics for the normal network load, number of packets in and out, the type of traffic on the wire, and so on. So this allows for easy identification then of abnormal activity, like unusual peer-to-peer communication, which could be indicative of a worm propagating itself over the network. Or we might have large volumes of traffic to or from a specific host or subnet or VLAN. That could be suspicious if we don't normally see that on the network. And also, we might want to make sure we have alerts in place to allow technicians to be notified when these things are happening. Now, that might be done within your operating system or with an intrusion detection or prevention system. Then there's the issue of rogue network devices that shouldn't be on the network. Now, we can control what devices and users can get on the network in the first place, whether it's wired or wireless, using IEEE 802.1x compliant devices like VPN appliances or Ethernet switches or wireless access points. So if they conform to IEEE 802.1x, We might limit their access to the network by using a centralized radius authentication server. Now, at the same time, even for the most basic Wi-Fi environment, MAC filtering is something that we could do to limit which devices can connect. Now, of course, it's very easy to spoof a MAC address with freely available tools, but that'll keep the basic people from trying to get connected to our Wi-Fi network. Certainly, Wi-Fi MAC filtering is not the only thing you should do to secure wireless network, but with defense in depth, it's always a combination of techniques. At the same time, we don't want to have rogue DHCP servers. In the Windows Active Directory world, there's this concept of DHCP server authorization, where when a new DHCP server is brought online, it needs to be authorized in Active Directory before it's actually active on the network. Now, that doesn't stop a malicious user from firing up a Windows host if they can get on the network in the first place and firing up a rogue DHCP server or a rogue access point. Then there's the issue of ARP cache poisoning, where an attacker essentially will fool all the machines on the network by giving them the MAC address of their malicious station as the router. So basically all traffic is funneled through the attacker's system and they get to see everything that way. Now, what should we be doing, at least on an ongoing periodic basis, to see if we have issues on the network, besides running intrusion detection and prevention systems and periodically capturing network traffic? Well, you might also run network scans and sweeps to discover and fingerprint network devices. For example, to discover if new devices are on the network that weren't there before, that shouldn't be. Now, also, when a network card is put into promiscuous mode when traffic is being captured on the network, this can actually be detected. So you should make sure you have a solution that can detect this, so that if we've got a malicious user capturing network traffic, it can send an alert to us. Also, we might want to track for abnormal connections from a network device to other devices. For example, it's not normal perhaps on our network to be probing for TCP port 22 from one host against many others. This could be indicative of some kind of reconnaissance by a malicious user looking for SSH daemons running on devices. So this can be configured then, in some cases, within your operating system software. You can generate alerts, or you might have a third-party tool, or again, it could be part of your intrusion detection and prevention system to trigger an alarm if too many of these SSH probes, for instance, occur in a short period of time. Now, bear in mind, we have to determine whether it's abnormal or not to have many failed connections, such as when probing ports on machines or failed login attempts. If you've established a normal usage baseline, it's going to be pretty easy over time to detect what's abnormal. In this video, we discussed network symptoms and response actions.